Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Mars 2020 Perseverance rover. So let's dive right into it. Well, this rover, Perseverance rover, the name was selected by a NASA competition. You can watch the video down below. And it's supposed to be launched in 2020. And the targeted launch date is 30 July 2020. There is a very good chance by the time you're watching the video, the launch has already been done. I hope it went successfully. And the target landing time is around 18 February 2021. So it will take time. It will take serious amount of time. So do not get too excited about it. Like it's a launch and then you wait. And this rover is launched on top of ULA Atlas V 541 configuration. Now, it's a very simple tested system, so they are going with this. And they have two mission insignia. One insignia is on the rocket, another is for the mission system. Now, if you think that design looks way too similar to Curiosity rover, you are not incorrect, because Curiosity rover was a complete redesign. We learned a lot by sending many rovers previous to that, but problem was that all of them are running on solar. Solar is not that powerful on Mars simply because Mars is much further away. So flat out, because of inverse square law, the solar panel that will give you 100 watt, it will not even come close to half of that on Mars. So reality was you can use solar panel, but it's not very effective, especially if you want to do long duration mission. And on top of that, dust storm can literally block out the whole solar system, and not to mention what the hell you're gonna do at night. And as your battery will decay over time, like as in battery will absorb the daytime charge and keep electronics heated up, because very low temperature will destroy your electronics. So that heater must be running. So over time it reaches a point where it's like, yeah, it cannot keep itself warm enough. So they decided to ditch basically solar system and went into radioactive system. So what does that mean? That simply means there is an amount of plutonium inside it which is radioactively hot, as in like 500 degrees Celsius hot. So that metal is very hot. Surrounded by a shielding, it's surrounded by what we call thermoelectric generator. So thermoelectric generator creates electricity with a temperature delta. So either you give it hot end or you give it cold end, it's gonna extract energy out of that. So hot end is 500 degrees Celsius, cold end is basically vacuum temperature, almost vacuum of Mars. So it was chosen as a power source. Now it's not very powerful. It is very long running, as in like your technical life expectancy is around 10 years without any noticeable degradation. But the puppy, it does not have too much power. It's very heavy, very long lasting, but does not have too much power. So it only provides 100 watt of power. And if you think that's not too much, well, you're correct. That's not enough. So what happens is power goes into basically 100 watts of power directly goes into lithium ion battery, and they charge up. They trickle charge and they charge up to the full power. And then once it reaches full power, then the max drain load would be started, basically moving the rover around, sending data, like the high bandwidth data and all that. So that's how the power management is done. So to do that, Curiosity was designed from ground up. Everything we learned from the previous rover, it was like, okay, let's redesign with new power system in mind, and everything was redesigned. So Curiosity was very expensive, and not to mention because of the size and mass and weight of it, it was so big that it is the upper limit of how much mass we can send with current rocket system. Again, if new rockets comes into the market, that's a different ballgame. But as of now, that's the biggest we can send. Flat out, we cannot send something bigger or heavier than that. So the design was like upper maximum. You can barely tweak it, a little bit here, a little bit there. You can't do much. And NASA had to save money and invest money in more payloads rather than like designing the rover itself again. They take that design. That design had almost everything tested out. Again, we have actual experience, but it had one severe flaw that we realized afterwards, that because of high inertia of this puppy, the aluminum wheels are not holding up. Basically, they're getting destroyed by sharp rocks very quickly. Like they thought like this will happen like a few decades into the if it lasts that long. Basically, that should not have happened, but it happened. So this time they realized they will make the wheels basically narrower, so it's much less constructive, and then they will make it thicker so it will last longer. That's the biggest difference. If I put both of the rovers, you can easily spot the difference based on the wheels. That's the biggest change, because they really don't want holes to be punched on the wheel. That's not basically advisable. And the core electronics is exactly the same as 15-year-old computer technology that you had in home. The reason for that is those technologies are much more radiation hardened by default, and then you add radiation shielding and all that, they become very reliable. We have tested it. Again, Curiosity rover did had it. We have testing data, but this time we are adding more cameras and more advanced algorithms. Basically, because of that learned experience we got from Curiosity, we are amping the capability of that hardware. So those are the upgrades. Basically, you take the Curiosity rover, you change the basically payloads and all that, but the core rover is the same with better wheels and better algorithms. Now, it is doing something very long term. Basically, it's going to do what we call sample collection. Now, so far in humanity's history, sample collection best has been done by Apollo mission. It went there and collected hundreds of kilograms of rock. So that is very successful mission written, because every other scenario is like, few milligrams and all that. So, and not to mention, we have not done that with Mars yet. And the reality is, no amount of instrument that we can send on Mars would even come close to one lab on Earth. And you're talking about the another benefit of that. If you are doing non-destructive scanning of equipments, basically you're not going to destroy the rock, basically melt it and then figure it out. You have basically your resolution would be limited by the tools you have. Now you have it here. Let's say you landed it here 1969. You got everything here. Now you're scanning it. Okay. 10 years passes, you have better equipment with better resolution, you scan it again, more data. That has been happening with the moon samples. That's why they are so precious so at this point in time. So what they want to do, basically NASA wants to do the same thing with Mars equipment. So basically collect as many rock sample as we can from Mars and then keep scanning it based on Earth's technology. So to do that, they have to do sample retribution, but right now we do not have any equipment that is powerful enough to go there, collect it and come back. Nothing powerful enough exists. So this is the first part of that. It's gonna have a rover. It has a drill arm. Now drill arm also carries a capsule, so to say. That capsule has multiple small pills, so to say, and that drill is gonna drill that. Depending on mission command, it could have a command like just drill and test it on your onboard equipment, or if it's interesting enough, they can send that basically soil sample into this pill, so to say, or capsule, and then seal it up and then just lay it on the ground. That's it. It's not going to be carried in the rover. Basically, rover has a cartridge, so to say. It has multiple capsules in it, and those capsules can be laid out depending on how many samples they collect. And this will be just left there. It's like it will be geotagged, Mars tagged, so to say, and it will be left there. Then there will be another mission which will have a lander and a rover. This rover will be very small. It will be just solar powered. It will be simple. It's just go as fast as you can, collect as many pills as you can, and then bring it back to the a lander. Now the lander will have a rocket, an actual rocket that will go from basically Mars surface to Mars low Martian orbit. The reason for that, you cannot design a rocket that is powerful enough, that you can land and launch it from surface and it will come to Earth. That would be too ludicrous at this point in time. So this puppy will just land there, and there will be orbiter that will catch it, basically, so to say. So there is multiple, it's so far out that they have not even designed anything specific to plan other than this system. So rover is like just the step one, go there, land, collect. By that time they will design the rover. By that time European Union is also working with this, basically ESA is also working with this. So by that time they are hoping that once we actually have the capsules, we have another mission ready with a rocket system and all that jazz. So it's a very far out planned mission. It's like you're not gonna see samples return to Earth by 2026 or even 30 if you are lucky, so to say. So it's a very long game plan, and the biggest benefit that we're gonna get out of that is once we launch from Martian surface, we're gonna get a very thorough understanding of rocket dynamics. Basically, right now we do not know when max Q happens on Mars. Now we have computational models, we have simulation data, and those are pretty good, but again, those are that simulation data. This will give actual data, what happens when you actually launch a rocket. So for that reason, it is very crucial to have. Not the Martian soil itself, that's a limited advantage, but that knowledge, what happens when you actually launch from the surface, that's priceless, so to say. Now, there are two core components of this mission that is really, really interesting. One of them is Moxi, basically this golden box, which will take carbon dioxide from the atmosphere, use heat, use catalyst, use electricity, all these three things combined, and it's going to split basically carbon dioxide into carbon monoxide and oxygen. And do that with two molecules, you have oxygen, and then you have carbon monoxide, two carbon monoxide independently outside, and that will be vented outside, and basically oxygen will be vented into a chamber. Basically, that's how he's supposed to feed oxygen into a habitat. They're not going to do electrolysis. That's not feasible for very large amount of mission, and not to mention for rocket system, no matter which rocket we send, we need oxygen. Oxidizer has to be there. So it does not matter whether it's hydrogen burning with oxygen or it's basically methane burning with oxygen. We need oxygen. So for this reason, this part must work. And once this part works, there is an even bigger mission plan, which is just a system that they're gonna land there and it's just generate oxygen. Just generate oxygen. Don't think about it, just generate the damn oxygen. So Moxi is very important and very interesting. So I have made a dedicated video down below. You can check the basically description down below where you will find that video. Then there is another high risk, high reward situation where you have a helicopter in it. Now the reason there is a helicopter is rovers are very slow. Like they're very, very, very slow. Most people cannot even comprehend how slow this is, and that's why I specified it only has 100 watts of power. It does not have like it's not fast and furious. So to achieve fast and furious like a kind of effective range, drone has been selected. Now problem with that is again atmosphere is very thin, so you need very big rotors. On top of that, because of the size restriction, you're not going to have a tail rotor, so they have to have dual, so it can compensate for its own rotation. Otherwise action equals your rotor is going to rotate clockwise and you're going to end up rotating counterclockwise. So they have to do that. This is solar powered, and its bare like best case scenario flight time is 90 seconds. Solar panel is going to charge the battery and it's going to fly for 90 seconds, best case scenario. Now be mindful, right now they have not placed hundreds of sensor and data and all that onto this, simply because this is a high risk system. If we figure this out, if this works as we expect, if we get this working, then the next mission will have a bigger, more powerful drone. But this is like a testing scenario. I have made a dedicated video about this also. So these two are very interesting aspects of it. Now you have to understand that most people are not excited about Mars missions, and there is a very good reason for that. Like, we are humans, we care about humans, not robots, or not about like oh, we now know this rock composition for this encyclopedia. That's not that interesting. However, this mission, it's not like Curiosity, where Curiosity has like figure out more science. This, while it does have that mission goals and like which rock composition, this and that symbol of ancient water and all that jazz, the interesting part about this mission is that it is a test bed technology which will allow us to test out many things that we must have for human mission. Remove everything else, it is the foundational test for human mission. So it is going to test living condition. It has a sensor, MEDA sensor, and it's going to detect what it would be like to like actually have the dust storm go through you. That will help us figure out like what kind of insulation, what kind of basically thickness of habitats we have to have in order to have basically long lasting life and all that jazz. It has microphones. Basically it's gonna hear what it feels like this is gonna be as close to us. We're gonna be like, what happens when you are actually there. So every aspect of this mission is designed for that kind of goal. That's why it has an oxygen generator. That's why it has a drone. It would be really helpful if we send humans there, and we have drones, we can cover a much larger area for science reasons and logistic purposes also. So it's very, very useful. And they are even testing fabrics of spacesuit, because let's say you built a spacesuit, you sent it there, everything was fine in first month, but astronauts could be there for 2 years. But turns out like after 3 months, your basically spacesuit degrades because of the radiation environment. How would you test that? You can't test that on Earth. So they have actual fabric sample from spacesuit material, and that is in the calibration, basically calibration plaque of this rover system. So we're gonna know what happens like once you are actually on Mars. Like what happens, like is fabric stretches too much because of low gravity, or what exactly happens. We have to test these things out. So for this reason, that testing sample has already been put there. On top of that, radio communication has improved a lot. By the time from Curiosity to now, that has improved a lot. So next generation of communication hardware is being tested on this, and mission after that will directly jump into laser communication. So lot of testing has been done on this mission. It's not as exciting as Curiosity, because again it's a copy of that, but in terms of human mission, this is like this, the amount of data we're gonna get from this mission is far more important for human landing than for science mission. So it's much more closer to what we really care about, rather than like okay, we have ancient water theory. So this was my presentation on basically Perseverance rover. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy, I urge you to press dislike. Press it twice to show me excess disappointment, and please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.